Hello, my name is Denisa, and this video is about logistic regression. In the first part of the video, I go over the intuition and math behind logistic regression. In the second part of the video, I explore the coding aspect of logistical regression using Python and the Scikit-learn library. For this project, I'm using a KAGGLE dataset, and the dataset I will link down below in the description section. I'm also uploading the code to my GitHub account, and I will link that as well. I hope you guys enjoyed this video, and it was a really fun project and had a good time doing it. Now let's go over the intuition behind logistic regression. Logistic regression predicts whether something is true or false. For example, if someone is pregnant or not, if an email is spam or not, if a tumor is malignant or benign. In these problems above, the variable y we are trying to predict can be seen as either 1 or 0. 0 is the absence of something, and 1 is the presence of something we are looking for. Logistic regression is a binary classifier, meaning it classifies something as either happening or not happening. The logistic regression model computes the weighted sum of input features, but instead of outputting the result directly like in linear regression, it outputs the logistic result. Logistic regression uses the sigmoid function to predict the probability of x, the independent variable, predicting y, the dependent variable. The sigmoid function is written as 1 over 1 plus e to the power of x. The sigmoid function produces an S-shaped curve that can convert any number and map it to a numerical value between 0 and 1 without ever reaching 0 or 1. If a value is greater than 0.5, then it is classified as 1. If a value is less than 0.5, it is classified as 0. The graph on the left shows if a person passed the test based on the number of hours they spent studying for the test. There is a high probability if someone has done lots of test prep, they will pass the test. There are several points on the graph. Instead of fitting a straight line like in linear regression, logistic regression fits an S-shaped curve to the data. The curve goes from 0 to 1. If the probability of someone passing the test is greater than 50%, we will classify it as passing, otherwise we will classify it as failing. Logistic regression can work with continuous data or discrete data. Continuous data is the number of hours studied. An example of discrete data would be whether someone is female or male. Now let's move on to the coding portion of the tutorial. So now let's start coding. I'm going to import pandas as PD, import numpy as np, import matplotlib.pyplot as plt, import seaborn as sns, and then I'm going to add in matplotlib inline, and I'm going to click run. We're adding the last line of matplotlib inline, so our data visualizations will show up on the page. Now let's import the data. Dataset equals pd.read CSV, and I'm going to type in churn, and then I'm going to tab. And it's going to grab our churn models here. PD read CSV allows us to read our data file. And now I'm going to type in dataset.head. What dataset.head allows us to do is view the top rows of our dataset file. In this dataset, we're looking at different customer metrics such as gender, income, country, age, and trying to determine whether that customer decided to stop their subscription to the product, aka the churn rate. Now let's do some exploratory data analysis. So I'm going to type in dataset.describe. What dataset.describe allows us to do is to get metrics such as average, minimum, and maximum for each column that has a numerical value. For example, if you look at the age column, it looks like the average age is almost 39 years old, the minimum age is 18, and the maximum age is 92. So I would encourage you to go over this chart and see if you find any patterns. Now I'm going to type in dataset.isNull.sum. What dataset.null allows me to do is to check if we have any missing values in our dataset. In this case, we're lucky and we do not have any missing values. So now I'm going to type in sns.boxplot x equals geography, y equals age, q equals exited, and the plot, the data equals setting that to dataset, and the palette equals to set3, and then I'm going to run this. So what this does is it creates a box plot and allows me to view the relationship of the distribution of our numerical data. In this case, it's the distribution of the age based on the country, whether someone decided to renew our product or not. Based on this chart, it looks like the younger folks were less likely to leave. So now I'm going to type in sns.countplot x equals exited, q equals gender, data equals dataset, what equals RDBUR. And I'm going to click run. This SNS count plot allows me to count the number of people that did not review the product based on their gender. Based on this graph, it seems that a higher percentage of males did not renew the product. Now let's move on to data preprocessing. So let me scroll up. So what I'm going to do is create an X and a Y variable. I'm going to grab the columns of our data set and setting those values to X. And I'm going to grab the last column of our data set and set that value to Y because this is the value we want to predict based on these values. I am skipping row number, customer ID, and surname because I don't think these will provide value to our data set. And I'm going to use credit score through estimated salary for our X variable, which will be used to predict Y, which is exited. So let me go type that up. X equals dataset.iloc colon, comma, 3 colon, -1 dot values, y equals dataset dot iloc, colon, comma, -1 dot values, and then I'm going to print out x, and then run that. Let me get rid of my comma right here and click run. Now let's move on to data encoding, which deals with pre-processing our data. As you've noticed, we have two categories that need some encoding: the country name and the gender of our customer. We can't use these type values in our logistic regression model, so we're going to have to use some encoding. So from Scikit-learn dot preprocessing, import label encoder, and then I'm going to type in LE equals label encoder, and then I'm passing in X, comma 2, lead dot fit, transform X, comma 2, then I'm going to click run. I'm going to correct this, transform, click run again. So we're going to use label encoding and one-hot encoding to pre-process our data. Label encoding should only be used when the categorical variable in question has a relationship such as gender or age. So for the gender row for this one, we're going to use the label encoder. In the country column, there's no relationship between the values in the columns. So in this instance, we're going to use one-hot encoder. One-hot encoding transforms each categorical feature with n possible values into n binary features with only one feature that is active at a time. It takes a column which has categorical data that has been encoded and then splits that column into multiple columns. The numbers are replaced by ones and zeros depending on which columns have that value. For rows which have had the first column value as France, the France column will now have a 1 and the other columns will have zeros. So now let me begin the process of doing one-hot encoding on the country column. So from Scikit-learn.compose, import column transformer from Scikit-learn.preprocessing, import one-hot encoder, CT equals column transformers equals encoder one-hot encoder 1. And then remainder equals pass through. And then I'm going to type in x equals np.array ct.fit transform, push in x, and then type in run. Now I'm going to split our data into a training set and a test set. So from Scikit-learn .model selection import train test split, and then I'm going to type in xtrain, xtest, ytrain, ytest. I'm going to set it equal to train test split. I'm going to pass in x, y, test size equals 0.25, and random state equals 242, and then I'm going to click run. So training data is data used to fit the machine learning model, and the test data is data used to evaluate the fit of the learning machine model. The goal is to estimate the performance of the machine learning model on new data, which is data that has not been used to train the model. So now let's move on to feature scaling. From Scikit-learn.preprocessing import standard scalar. SC equals standard scalar. Xtrain equals sc.fit. Transform. Xtrain. Xtest equals sc dot transform x test. Then I'm going to click run. So let's check out the error. This is like a normal part of programming. So I see that could not convert string to float male. So let me go back, and I see actually that this comma right here should be an equal sign. So let me run this again, and let me run the next items. Let me actually restart my kernel and run all. And now it worked. So many machine learning algorithms perform better when numerical input variables are scaled to a standard range, and this is what the standard scalar does. So the input variables may have different units, for example, feet, kilometers, hours, and those in turn may mean the variables have different scales. Differences in the scales across input variables may increase the difficulty of the problem being modeled. Standardizing a data set involves rescaling the distribution of values so that the mean of the observed values is 0 and the standard deviation is 1. So now let me move on to logistic regression. From Scikit-learn .linear model import logistic regression. logistic regression equals logistic regression. Logistic regression dot fit x train y train, and then I'm going to click run. So let me make sure I did everything right. Oops, so let me copy and paste this to here. So much easier. Okay, I'm going to click run again. So what we are doing here is creating a new instance of the logistic regression object and calling the fit function on our instance and passing through our x train and y train data. Now let's move on to model predictions and evaluations. So predictions equals logistic regression dot predict x test. I'm going to run that. And I'm going to type in from Scikit-learn dot metrics import classification report. I'm going to print classification report y test, and then predictions. I'm going to click run. So what we are doing here is looking up the precision, recall, F1 score metrics for our data. Now I'm going to type in from Scikit-learn dot metrics import confusion matrix accuracy score ypred equals logistic regression dot predict x test cm equals confusion matrix y test y pred, and I'm going to print the cm, and then I'm also going to do is put in accuracy score y test y pred. Then I'm going to click run. What we are doing here is creating a confusion matrix. The left top corner is the number of values that are supposed to be positive, and we classified as positive. The top right column is the number of people that did not exit, but we mark them as exiting, also known as false positives. The bottom left column is the number of false negatives, or people that did exit, but our model predicted they would not. The bottom right column is the number of people that actually exited the product and were marked as exiting the product. And the very bottom score is the percentage and how accurate this model was. So thank you so much for listening to this tutorial. If you liked it, please like and subscribe to my channel. I would really appreciate that.